For project 150, Transistor, we're going to use this circuit, and we have included the NPN, or Q2 transistor, right here. I am going to turn on the slide switch. The RV lever is closest to me. Nothing happens. Now I'm going to gradually move the RV lever away from me and watch the LEDs. The white LED comes on and gets bright, and then the red LED comes on and gets bright. It's on its highest setting now. Now when I move the RV lever toward me, the red LED slowly turns off, followed by the white LED. Let's do that one more time. White LED, red LED. Transistors amplify electric current, but in this particular circuit, the adjustable resistor is controlling the current that goes to the transistor through the red LED, and then it amplifies the current. It controls a larger current through the white LED. At some settings on the adjustable resistor, the control current is too small to light the red LED, but the transistor amplified is large enough to light the white LED, which is the case here on this particular setting. The white LED is on, but the red LED isn't. The first transistor was invented in 1947, and it allowed electronic devices, such as radios and televisions, to be a lot more compact. And it also allowed them to work more efficiently too. For instance, radios would start up instantly when transistors replaced the old cathode ray tubes in older models. 151, another transistor, uses this circuit, and I will turn on the slide switch. Now both LEDs are on at full brightness when the RV lever is closest to me. But I'm going to gradually move it away from me. The red LED gradually turns off, and then the white LED slowly turns off. Now both LEDs are off, but now I'm going to move the RV lever back toward me slowly. The white LED comes on first, followed by the red LED. The transistor that is being used in this circuit is the PNP, or Q1 transistor. It works similarly to the NPN transistor demonstrated in the previous project, except the current is flowing in opposite directions. That's why the LEDs are on when the RV lever is toward me and off when they are away from me. The next four projects, 152 through 155, which will be demonstrated in separate videos, will focus on an interesting component which I've used in countless other projects, but these projects will explain in detail about it, the capacitor. The capacitor is a component which stores electricity for a particular use in an electrical device. Project 152, Charging and Discharging, will demonstrate the basic principles of this component. You can see that we have both the red and white LEDs as well as the slide and press switches. We also have two resistors. We are going to turn on the slide switch, and the red LED briefly lights up, and after a few seconds we're going to turn the slide switch back off. That is because we are charging the capacitor when we turn on the slide switch and then turn it off again. The capacitor now has electricity in it, and then we will push and hold down the press switch and watch the white LED carefully. The white LED comes on for a period of time, but then it gradually dims until it is completely off. That is because the electricity in the capacitor has been discharged to go through this portion of the circuit and light the white LED for a short period of time. In a way, a capacitor is a battery. It can be charged and then discharged, hence the name of this project. Turning on the slide switch for a few seconds charges the capacitor, and once again the red LED comes on briefly, and now it's ready to be used as a temporary battery. Push the press switch and hold it down again. Like resistors, capacitors have values that determine how much electricity they can store. And the resistor determines how quickly the charge is inserted and then released from the component. The higher the value of the capacitor, the more electricity it can store. Now we can swap the locations of the two LEDs and see what happens now. The white LED comes on and it's pretty bright, even though it is just charging up coming on when the capacitor is being charged. Push the press switch and the red LED briefly comes on. Let's try that one more time. Project 153 is mini capacitor. We're using the same circuit, but we replaced the C4 capacitor with the C2 one. And I think this is how you insert it. We're going to turn on the slide switch. Nothing happens. Turn it on for a few seconds and then turn it off. And then watch the white LED as I hit the press switch. It blinks briefly. I'm going to zoom in close up so that you can see it better. It'll be easier to see if I zoom in on it. It just flashes. Why doesn't it stay on like in the previous project? That's because the C2 capacitor stores a lot less energy than the C4 capacitor. Capacitors store their energy in what is known as a farad. In this case, it is being measured in a microfarad, which is symbolized by the U ahead of the F. A farad is a unit that measures capacitance, and it was named after the British scientist Michael Faraday, who invented the dynamo and pioneered many other electrical discoveries. This capacitor has only 0.1 microfarads, while the C4 capacitor has 100 farads. So that means that this capacitor stores only 1,000th of the electricity that the C4 capacitor can store. So it makes perfect sense that the white LED will just blink when I hit the press switch. Project 154, Adjustable Charging and Discharging, uses the same circuit as the previous two projects, except we replaced the R3 resistor with the adjustable resistor, and we will turn on the slide switch. The red LED flashes briefly. Now we're going to turn the slide switch off and hold down the press switch. The white LED comes on and then it will turn off. Now we can try this on different settings for the adjustable resistor. Now I have it about halfway. Turn the switch on and off again. And now hold down the press switch. The white LED will come on and slowly turn off. The effect is best viewed in a dark room, but you can tell that it is still on and gradually turning off. Now we will try it on the highest setting. Remember, when we turn on the slide switch, we're charging up the C4 capacitor, and then we hold down the press switch, and that discharges the capacitor. Now what's neat is that the adjustable resistor controls how fast the capacitor discharges. In this particular circuit, when the lever on the RV is closer to me, the capacitor discharges much more quickly, but when it's away from me, it takes the longest to discharge because there's more electrical resistance in this part of the circuit that is keeping the electricity from flowing out of the capacitor quickly. You may have also noticed that when the adjustable resistor is at its lowest resistance setting, the white LED is very bright, but it quickly dims because the electricity flows through the circuit much more quickly. The adjustable resistor acts like a door or gateway that limits the amount of electricity flowing. Project 155 is mini battery. This project is similar to the previous one, but it may be easier for you to understand how the capacitor works. And we modified this circuit, but you can see that there are no LEDs attached to it. That is because we're going to use one LED, the white LED, and we will be moving it from two different positions. The first position we will place it in is at points B and C. And when we place it there, it may briefly light up, but then it will go out. That's because the C4 capacitor is being charged. The adjustable resistor is at its lowest resistance setting, and now we will move the white LED over to the other 2 points, A and B. And you can see that comes on, and it is bright for a very brief period of time, but it quickly dims and goes out as the capacitor discharges. In this setting, there's very little resistance to stop the flow of electricity out of the capacitor, so it will be used up very quickly. Now we will move the adjustable resistor to about halfway, and we will move the white LED back to points B and C. It may turn on briefly, and then we will move it back to points A and B. It's not near as bright as it was when the adjustable resistor was at its lowest setting, but it stays on a lot longer. And that is because there is a lot more resistance in this part of the circuit, and the electricity takes longer to flow out. I'm not going to wait for it to turn off completely because I think it's still on but very, very dim. But we can now move the white LED back after we move the adjustable resistor to its highest setting. Place the white LED there for a few seconds, and then we will move it back to points A and B. Once again, it's extremely dim, but it's probably going to stay on for a much longer period of time because the resistance is greatest at this setting, and the electricity will flow through the LED for a longer period of time before it is all used up. (156) is photocurrent amplifier. We're going to use this circuit, and you see that we have included the white and color LEDs in addition to the phototransistor and Q2 transistor, MPN transistor. We will turn on the slide switch, and both LEDs light up. You will see that in this circuit, the color LED is a lot brighter than the white LED. We will vary the amount of light that hits the phototransistor, and we can cover it and see what happens. The white LED dims significantly, and it might be completely off right now, but the color LED, and so does the color LED, it is a lot dimmer but still remains on. When I remove my hand, both LEDs get brighter. That is because the electrical resistance decreases when there's more light on the photo transistor. Now we will swap the locations of the two LEDs and compare the brightness of them now. Now the white LED is considerably brighter than the color LED. The color LED still flashes and changes colors, but it is a lot dimmer. When I block the phototransistor, the color LED turns off completely while the white LED dims. 157 is LEDs and transistors. We're going to use the same circuit but replace either the color LED or the white LED with the red LED, and then we will compare all three LEDs in both locations. When I turn on the slide switch, the red LED is a lot brighter than the white LED, but covering the phototransistor will turn off the white LED and significantly dim the red one. Now when I swap the locations of the two, the white LED is completely bright, but the red LED appears to be off, and covering the phototransistor just dims the white LED. Now I will replace the white LED with the color LED, and look at that. It's a lot brighter now. And then I will put the red LED, and now the color LED is barely lit. Project 158 is PNP Amplifier. This project is similar to the previous one, except now we have modified the circuit to include the PNP or Q1 transistor. And let's see what happens. The color LED is very bright, but the white LED is dim. Now when I cover the phototransistor, the white LED will go off and the color LED will dim a bit. But when I remove my hand, it becomes brighter and the white LED will come back on. It's a little bright in here, so it's hard to see the light from the white LED since it's not at full brightness. But we can swap the locations of the LEDs. And now the white LED is very bright, while the color LED is dimmer. We will then replace it with the red LED, and it is pretty bright. I will then replace the color LED with the white one, and it is extremely dim once again. For project 159, photo control, we're going to use this circuit, and we will turn on the slide switch and then hit the press switch. The adjustable resistor lever is closest to me. The color LED comes on, but it will gradually become dimmer and turn off. Now what will be determined by how fast the LED discharges, the capacitor right here discharges, is the setting on the adjustable resistor as well as the amount of light on the phototransistor. Right now I think it's on the lowest resistance setting, and the more light there is on the phototransistor, the quicker the color LED will discharge. I will turn off the switch to reset the circuit, and I'm just going to move the adjustable resistor further from me. Now I think it will be on for a shorter period of time. But once again, if there's more light on the phototransistor, the capacitor will discharge more quickly. Do this one more time. Try to expose it to more light so that it works better. It probably won't stay on as long now because the light is on the phototransistor is allowing the capacitor to discharge more quickly. I'm not going to do this, but you could use either the white LED or the red LED as well.